Alright, hello boys and girls. Today we're going to be multiplying and dividing decimals. Again, please make sure you take very good notes, and if you have any questions throughout this lesson, make sure you jot them down so that we can go over them tomorrow. We're going to start by looking at multiplying decimals. When you multiply decimals, it's a little different than when we add and subtract. When we added and subtracted decimals, it was so important to line up that decimal point. When you multiply, that's not important. We're going to pretend like those decimals aren't even there until we get to our answer. On this one, we have 3 and 24 hundredths times a negative 56 hundredths. On a problem like this, we're going to just start by pretending that is the number 324 times 56. Pretend like those decimals aren't even there, and everyone go ahead and write down that 324 multiplied by your 56. Notice how I didn't have to worry about any decimals being lined up. We're just thinking of this as a whole number. So we can go back now if you'd like and put those decimals in. Those decimals go right there. There is a 0 in front of there. It's not necessary to put it there, but you can. Either way, you're going to get the same answer. I'm going to put my negative sign in, and we know when we multiply a positive by a negative, we're going to get that negative answer. But this decimal, we're not going to do anything with it until I get to my final answer at the bottom. So 6 times 4 is 24. We're going to put the 4 down, bring that 2 up. 6 times 2 is 12. 12 plus 2 is 14. 6 times 3 is 18. 18 plus 1 is 19. Before we multiply that 5, we need to put in that placeholder. And then we're ready to multiply 5 times 4, which gives us 20. 5 times 2 is 10. 10 plus 2 is 12. Carry that 1. Now we have 5 times 3 is 15. 15 plus 1 is 16. We're going to put that 16 right down here. And the next step is to add those together. So I add up my 4 plus 0. 9 plus 2 is 11. Carry that 1. 1 plus 1 plus 6 is 8. And bring that 1 down. Now we go back to the problem. We know it was a positive times a negative, so we're going to get that negative answer. Now we look at our decimals. The way you figure out where your decimal goes in your answer is by counting up how many decimals are there how many numbers are there behind your decimals in your problem. So if I look here, I have 2 numbers behind the decimal here, and I have 2 numbers behind the decimal here. 2 plus 2 is 4. So I have 4 numbers behind the decimal point. I need 4 numbers behind the decimal point in my answer as well. So if I have 1, 2, 3, 4, we're going to have 1, 2, 3, 4 numbers behind your decimal point here. Okay, when we look at this number, we read that number as negative 1 and 8,144 ten-thousandths. That's how you're going to read that number. It's a big one, okay? Make sure if you have any questions on this problem that we're jotting those down and that we're taking good notes as I go through this. On a problem like this, we have negative 2 and 6 thousandths times a negative 3 and 4 tenths. On a problem like this, it doesn't necessarily matter which number you put on the top, but I always like to put the one that has the most digits in it, the longest number. So I'm going to put that 2 and 6 thousandths on the top, and I'm going to put that 3 and 4 tenths here. Remember, we're kind of just ignoring those decimals for now. We're multiplying this like it's 2006 times 34. Keep in mind it's a negative times a negative, which means we know we're going to get that positive answer. I don't even have to worry about my negatives anymore. We're going to go ahead and multiply this out. 6 times 4 is 24. Put your 4 down, carry the 2. 4 times 0 is 0. 0 plus 2 is 2. 4 times 0 is 0. 4 times 2 is 8. Next we need to put that placeholder in. That's why I'm going to put the 0 down here. 3 times 6 is 18. Carry that 1. 3 times 0 is 0. 0 plus 1 is 1. 3 times 0 is 0. And 3 times 2 is 6. Next up, we're ready to add those together. 4 plus 0 is 4. 8 plus 2 is 10. 1 plus 0 plus 1, we get that 2. 8 plus 0 is 8. Bring that 6 down. Again, we know it was a negative times a negative, so it's going to be a positive answer. So our last step is just to look at how many numbers I have behind my decimal points in the entire problem. If you look here, I have 1, 2, 3 behind the decimal point here, and I have 1 here. 3 plus 1 gives me 4, so that's 4 numbers that are behind my decimal point in my problem. That's how many numbers I need behind my decimal point in my answer. So I'm going to go ahead and I'm going to put that 1, 2, 3, 4. My decimal point's going to go right here, and I have 6 and 8,204 10,000ths. That's how we're going to read that number. That's your final answer. On one like this, we need to plug in a number for p. This tells us we're going to do negative 1 500 times p. We're going to multiply those together, and it tells us what p is. So we're going to go ahead and I'm going to put my negative 1.05 up here. We don't really need that 0 in the front. You can put it there, but it's not necessary. I'm not going to put it in mine, but if you'd like to put it in yours, you're more than welcome to. We're going to go ahead and multiply what's 5 times 4. We get 20. 4 times 0 is 0. 0 plus 2 is 2. 4 times 1 is 4. All of the rest of these are zeros, so we don't necessarily need to multiply those out. But here's where it gets a little tricky. When I look at my problem, I count how many numbers I have behind my decimal point. I have 2 here in this number, and I have 3 here. So 1, 2, 3, 4, 5. There are 5 numbers behind my decimal points in the problem. I need 5 numbers behind my decimal point in my answer. Right now, we know my decimal point is at the end of the number. But if I go up to here, that means there's only 3 numbers behind my decimal point. I need 5. Whenever there's not enough, that's okay. You simply add zeros in the front. So I now have 5 numbers in front of that decimal point. I'm going to put my decimal point right here. Again, this 0 at the end, it can kind of roll off. You don't necessarily need it, but it's also not wrong if you leave it. It's okay if we leave it. You're not going to be marked off, but again, you don't need it. So if you take that 0 away, we have 42 10,000ths. It's not done though, because I need to go back and I see I have a negative times a positive. When I have a negative number times a positive number, we're going to get that negative answer. So I get negative 42 10,000ths. All right, next one, we have negative 80 times 4 and 54 hundredths. On a problem like this, just because your negative 80 comes first does not necessarily mean you have to put that number on the top. You can, and you'll still get the right answer, but like I said earlier, I usually put the one that has more digits in it on the top. So we're going to write that as 4 and 54 hundredths times our negative 80, and we're ready to multiply. You don't necessarily have to multiply the 0 out if you know to leave the placeholder, but we'll go ahead and do it just if you need to see that visual. 0 times 4 is 0, 0 times 5 is 0, 0 times 4 is 0. Now I have to go ahead and put that placeholder in, and I'm ready to multiply my 8. 8 times 4 is 32. 8 times 5 is 40. 40 plus 3 is 43. 8 times 4 is 32. 32 plus 4 is 36. Now when I add these up, I should get the same number that I just worked out because I'm just adding 0. Okay, it's a negative number times a positive number. When we multiply and I have unlike signs, that's when we're going to get that negative answer. Now I go back and I count how many numbers are behind the decimal point in the problem. If you look, 80 is right here. There's no decimal point in that problem, but it's really just invisible. There's always a decimal point at the end of the number, but you don't need it if you don't have any numbers back behind here. Okay? So we're going to cross that out. We have 2 numbers behind the decimal point here. I need 2 numbers behind the decimal point here. Again, you don't really need a 0 on the end, so you can go ahead and cross that out. We end up getting 363 and 2 tenths. A negative 363 and 2 tenths. Alright, and the last multiplication problem we're going to do is a negative times a negative. Right away when you look at that problem, you should know that you're going to get a positive answer, so we no longer have to worry about our negatives. Again, I'm going to put the one with the more digits in the number on the top, and I'm going to put that 4.5 or 4 and 5 tenths right below. 5 times 3 is 15. Carry that 1. 5 times 2 is 10. 10 plus 1 is 11. 6 times 5 is 30. 30 plus 1 is 31. Put that placeholder down, and we're ready to multiply that forward. 4 times 3 is 12. 4 times 2 is 8. 8 plus 1 is 9. Make sure we're lining them up right. 4 times 6 is 24. Now we're ready to add them together. 5 plus 0 is 5. 1 plus 2 is 3. 1 plus 9 is 10. 1 plus 3 is 4. Plus 4 is 8. And bring that 2 down. Again, we already know it's going to be a positive answer, so I can go ahead and look at my decimals. I have 3 numbers behind my decimal points in my problem. I need 3 numbers behind my decimal point in my answer. I'm going to go ahead and put that in, and we get 28 and 35 thousandths. We're going to look at division now. This might look a little small, so I'm going to go ahead and go through it as well, but make sure there are rules that we have to follow. You might hear me refer to the division bar as a house. We always want to put the first number inside the house. So this number 63 that they have in this problem, that always goes inside the house, inside your division bar. The other number is going to go on the outside. That number that's on the outside of your house cannot have a decimal in it. Our whole goal is to take that number and turn it into a whole number. So we're going to have to move that decimal point. I can't move that decimal point without doing something to the inside as well. Whatever I do to the outside, I have to do to the inside. So I'm going to rewrite this problem where I have a little bit more room. Okay, since I have 5 and 25 hundredths, I need to move that decimal point to turn it into a whole number. If I move it 1, I'm at 52 and 5 tenths. That's still not a whole number. So I need to move it 1 more, and I end up with 525. If I move it 2 places here, I need to move my decimal 2 places on the inside of my division bar as well. Currently, my decimal is at the end of that number. If I move it 2 places this way, there's nothing there. So what I need to add are zeros. Okay, so I'm going to rewrite this problem as 6,300 divided by a negative 525. That's a big number to divide, but if we write it as a long division problem, I know we're very capable of doing it. We're going to figure out how many times 525 goes into 630. It goes in there 1 time. We're going to go ahead and subtract 525 below. Okay, we can't do 0 minus 5, so I'm going to borrow. 10 minus 5 is 5. 2 minus 2 is 0. 6 minus 5 is 1. I then have to bring that 0 down. We need to figure out how many times 525 goes into 1,050. If you're not sure, you can always multiply it out. If you think it's 2, but you're not sure it's exactly 2, go ahead and try it and see if it works. 5 times 2 is 10. 2 times 2 is 4. 4 plus 1 is 5. 2 times 5 is 10. So it works out evenly. So we can go ahead and put that 2 up there. When I subtract, I'm going to end up with 0 at the bottom of my division bar. I'm not done because I was dividing a positive number divided by a negative number. We know that when we divide and we have different signs, we're going to get that negative answer. That's where we get negative 12. So when we divide, the whole thing we need to remember is that we can't divide with the decimal on the outside. You have to turn that into a whole number. But if you move any decimals on the outside, you have to do the same thing to the inside. On this problem, keep in mind first number, or if it's written as a fraction, it's going to be top number. Top number or first number always goes inside the house. So we're going to take this number, we're going to put it inside that house, and we have 1 and 74 hundredths divided by 3 hundredths. Again, I can't divide with the decimal on the outside. I need to move that until I get a whole number. If I move it 1 place, that's 3 tenths. That's not a whole number. I need to move it another place to get that 3. I'm going to rewrite that as 3 down here. If I moved it 2 places on the outside here, I need to move it 2 places on the inside as well. So this is going to become 174. I have a positive divided by a positive, so I don't have to worry about any of the signs. We can go ahead and divide. How many times does 3 fit into 17? Fits in there 5 times. 3 times 5 is 15. We're going to subtract 7 minus 5 gives us 2. Bring that 4 down. How many times does 3 fit into 24? It fits in there 8 times evenly. So when I subtract that out, I'm going to get 0, and I know that I'm finished. So when I divide that, I get a positive 58. You had a really small number divided by a really small number, and you got a pretty big number. What you need to think about is when you have something really little, like think pennies. How many pennies fit into a dollar? You have something pretty small, but when you have something really small, and you're trying to figure out how many of those fit inside, it's actually going to be more. When you have something really little that you need to fit inside something bigger, you are going to divide and get a larger number than you started with. And we'll talk about that further tomorrow in class when we're doing some of those activities. On this one, same thing. First number or top number, if it's written as a fraction, always goes on the inside. So we're going to write that as 3 2/10 divided by 2/10. Again, I can't divide with a decimal on the outside. I need to turn that into a whole number. If I were to move it this way, I'm going to get 2/100. It's going to get smaller. In order to turn it into a whole number, I need to move my decimal to the right. So I move it one place to the right, and I now have 2. If I move it one place to the right here, I also have to move it one place to the right here. Now I'm going to rewrite that so it's a little bit easier to see. And we say, how many times does 2 go into 3? Goes in there 1 time. 3 minus 2 is 1. Bring that 2 down. 2 fits into 12 6 times. And we end up getting 0, so we know that's our answer. Okay? I'm going to add a negative onto this one, so when you write this problem down, write it down as negative 9 6/10 divided by 4/10. It's not really going to change how we solve the problem, it's just going to change our final answer in the end. So when I write this, I'm still going to put top number or first number on the inside. So I have a negative 9 6/10 divided by 4/10. Again, I can't divide with that decimal on the outside. I need to move that decimal one place over to make it a whole 4. If I move it over one place here, I have to move it over one place here. So I'm going to move this one place over, and we end up with negative 96 divided by 4. Now, when I divide a negative divided by a positive, we're going to get that negative answer. Just go ahead and put that up now so that we don't forget about it later. How many times does 4 fit into 9? Fits in there 2 times. 4 times 2 is 8. We're going to subtract 9 minus 8 is 1. Bring that 6 down. 4 fits into 16 4 times. And we know that we're going to subtract to get 0. So we end up with negative 24 as our answer. Alright, the last problem we're going to look at today, I'm going to make them both negative. I'm going to make this negative 251 43/100 divided by negative 3/10. Again, first number always goes on the inside. If I have a negative divided by a negative, you really no longer even have to worry about your negatives because you're going to get a positive as an answer. But we're going to go ahead, we're going to write that with 251 43/100 divided by our 3/10. Again, when I have a decimal on the outside, we're going to move it until we get to a whole number. I get that 3, and I'm ready to move it one place over here. Keep in mind, if you do anything to the outside, you're going to have to do it to the inside. I'm going to rewrite that. And we're going to ask ourselves, can 3 fit into 2? Since it can't, we're going to say, can 3 fit into 25? It can fit in there 8 times. 24 goes below. When I subtract 5 minus 4 is 1. Bring that 1 down. 3 fits into 11 3 times. We're going to put that 3 up. Put 9 below. 11 minus 9 is 2. Bring that 4 down. 3 fits into 24 8 times. And one thing I need to point out on this problem that I didn't, if you have a decimal in your problem still, it's going to shoot straight up. So just shoot straight up in the problem. Okay, now we can continue. We get 24 here, subtract, I get 0, and bring that 3 down. 3 fits into 3 one time, so I'm going to put that 1 here, and when I subtract, I do end up getting 0 down here. So I end up getting a negative divided by a negative is a positive. I get 838 and 1/10. Again, if you have any problem, let's say I have, let me rewrite that. If I have 511 divided by 3, I don't have a decimal on the outside in this problem. And that's okay. I don't have to do any moving. But since I have a decimal on the inside, this is where that decimal is just going to shoot straight up. Okay? Again, 3 does not fit into 2. We know it fits into 25. It fits in there 8 times. 24 goes below. 5 minus 4 is 1. Bring that 1 down. 3 fits into 11 3 times. 3 times 3 is 9. 11 minus 9 is 2. And we're going to bring that 1 down. And 3 fits into 21 7 times. Evenly. So again, if you don't have a decimal on the outside, you don't have to do any moving. You're ready to just shoot that decimal point straight up. Okay? Make sure if you have any questions about that, we will go over more tomorrow like this. But write down that you had a question about it. We can go over any questions you have. Okay? Thank you for staying and listening to the entire video. This week's key phrase is orange balloon. I'd like you all to write that down in your notes. If I see that you have the phrase orange balloon written down in your notes, you will get a treat tomorrow. I don't want you to tell your friends. You did hard work listening to this whole thing, taking good notes, and writing down any questions you had. So thank you for listening and staying through for the whole video, and I'll see you tomorrow.